Okay, here's another example. So we're going to solve this one, okay? But again, we're using the quadratic formula, okay? I mean, here you probably could factor this really easily actually, but we're going to use the quadratic formula here just to help demonstrate it, okay? So again, so it's already in standard form, okay? What we also need are A, B, and C, right? So we can see that since we can see that A is 1, remember, if the coefficient is not written, but the term is there, the coefficient is understood to be 1. So we have A is 1, B we have as 6, and C we have as 9, as you can see. Okay, so now what we're going to do is we're going to use the formula. So we have this now. And again, we're just replacing A, B, and C into the formula here, right? B is 6, so we get minus 6 here. Again, I'm not putting X in at all. I'm just putting numbers in, just the coefficients. So we have 6 squared minus 4 times 1 times 9, right? So we have 36, which is 6 squared, minus 36. And A is 1, so we're dividing by 2. The whole thing is divided by 2. But notice that the radicand here, you know, what you're taking the square root of, that becomes 0. So we actually have negative 6 plus or minus the square root of 0 over 2. But the square root of 0 we should know is 0. So here we get negative 6 over 2, which is negative 3. In other words, here, we're only getting one solution. It's not like the previous example where we got 2. In the previous example, this radicand here was positive, which essentially is why we got 2 solutions. Whereas here, that radicand is 0, which really is why we only get one solution. I mean, we have negative 6 plus or minus 0, but you know, adding and subtracting 0 doesn't do anything, doesn't add anything. So we only have one solution here. That's good. Let's do another one. This one. Now, notice right away, this is not in standard form, right? This is equal to negative 5. We want equal to 0. We don't want the negative 5 here. Okay, so what do? We're going to get the 5 out of there. Excuse me, the negative 5 we're going to get out of there. We're going to add 5 to each side. And that's what I'm doing here. Because again, we want the right-hand side equal to 0. That's what happens here. Here, we're now in standard form. And now we can, once we get A, B, and C, now we can do the quadratic formula. Again, you don't want to use the quadratic formula here because your answer is not going to be right. All right. Anyway, from here, we have A is 1, right? The coefficient, the term is here, but we don't see a coefficient. It's understood to be 1. Here's the term. We have B is 3. C we have is 5, and we plug it in. And no, there's no mistake here. You can see that we have negative 3 plus or minus the square root of 3 squared minus 4 times A times C over 2 times A. We get this. Okay? And notice here we have the square root of negative 11. Well, we learned already, I think when we did P6, is that you can't take the square root of a negative number. In other words, the square root of a negative number is not a real number. So since we're not dealing with complex numbers, this tells us that we have no solutions because the square root of a negative is not defined. It's not a real number. So, excuse me. So it follows that there's no solutions here. But if you were to go back and look at these examples, you would see that what really determined the number of solutions was this radicand, this b squared minus 4 times a times c, this thing. Well, that's really important. That determines the nature, that determines how many solutions there are. And because of that, we call it the discriminant. So the discriminant of this quadratic here is b squared minus 4 times a times c. It does also have graphical implications. For now, we're looking at its implications relative to the quadratic formula. And that's what happened, or in other words, to this equation. But this is what we have. Right? So if it's positive, we saw there are 2 solutions exactly. If it's 0, as in the second example, right, then there's only 1 solution. And if it's negative, since we're only dealing with real numbers, we have no solutions. I mean, complex numbers come about because you allow the square root of a negative. But we're not doing that. Okay. So that's a discriminant. Again, it does have graphical implications, which we'll get to later on in the course. So here's another example. Let's say we want to solve this one. We're going to use the quadratic formula. Okay, that's good. So again, we already have the standard form. It's already in standard form, right? Because again, this quadratic here is equal to 0. This is equal to 0. So it's already in standard form. Just by comparing the standard form here and our example, we can see what a, b, and c are. A, right? The leading coefficient is 1. B is the coefficient of x, which is 2. C is -1, it's the constant term. Again, you have to include the negative when you subtract. I know I keep saying that, but I've seen students in the past forget the negative sign. Maybe I did it when I was younger. I don't know. I don't remember. But you know, I've seen people make that mistake, so that's why I'm saying it a lot. Okay. So from here, we use the quadratic formula, and we're plugging in. Good. So we have negative b, which is -2, plus or minus the square root of 2 squared. B is 2, right? So we get 2 squared minus 4 times a. A is 1 times c is -1. All over 2 times 1, a. Notice again, here in the radicand here, we have 4 minus -4, which is 4 plus 4. And so we get 8. So we know there's 2 solutions, and we know what they are. But we can do better than radical 8. In other words, we can simplify the square root of 8. I mean, we've seen before that the square root of 8 is not simplified because 8 has a factor besides 1 that's a perfect square, namely 4. Right? So 8 is 4 times 2. We factored out that square, and then we take square roots, as you can see. Okay? And square root of 4 is 2, so we get 2 radical 2. I just plugged that in here, as you can see. Then, I mean, you could divide into each term. I just wrote it in an equivalent way, as you can see. Kind of going backwards with adding and subtracting fractions. But now you can see that you could divide a bit, and that's what I'm doing. Again, you only have to simplify if I ask you to. But you should know how to simplify the square root of 8. Something like that could be on it. Could be on the test. All right. So we get our 2 solutions here, as you can see. We get -1 plus the square root of 2 and -1 minus the square root of 2. So that's what we get. That's good. All right, now, let me pause this. Because now what I want to do is I like to give examples for everyone to